Hey, awesome people. Mr. C here with another fractions video. Make sure if you learn anything new at all, click that like and subscribe button. Join us as we continue making math understandable and challenging. This video is going to be adding fractions with unlike denominators by replacing given fractions with equivalent fractions in such a way as to produce an equivalent sum of fractions with like denominators. A lot of words there, but what we were going to be doing is we were going to be adding fractions with unlike denominators using a standard strategy, okay? This strategy is going to be the standard approach for solving, so that's going to be what we're focusing on in this video. You will find in the description below everything that we have done, second grade, third grade, and fourth grade fractions. Check all of those out. Parents, teachers, also in the description below. There are 2 links for IXL. IXL is an incredible program I have used in my classroom. It is a great tool for students to get some independent practice on different skills. 2 links, one of them is a free 7-day trial and another one is a 20% off an annual or monthly membership. Check those out. They are awesome program. All right. Again, this is our teaching video for using a standard strategy to add fractions with unlike denominators. Let's get busy. All right, ladies and gentlemen, before we start on our first problem, like we always talk about here at Math Mr. C, make sure you have a growth mindset. A growth mindset means that you are going to make mistakes, but you are not going to give up. Our mistakes help our brains grow. We know that things are going to be challenging, and the more we practice, the better we're going to get. So make sure you're asking good questions and trying these problems on your own, all right? So here we go. We've got 1/4 plus 2/3, and to solve this, we are going to be using what you'll kind of hear me say is the standard strategy. And what I mean by that, a standard strategy is a little bit different from what we've done already. So if you've been keeping up, we used models in our last video to add fractions with unlike denominators. Now we're going to kind of build on that. And I'm going to show you the strategy that is really common to people that are older than you. So if you ask your parents, if you ask older siblings, if you ask grandparents, this is kind of going to be the way they show you how to add these types of fractions. And this is going to take a little bit of practice, so stick with me here. So notice we've got 1/4 plus 2/3. The first thing I notice is that these denominators here are different. So because those denominators are different, we can't add them quite yet, all right? We can only add our fractions. Well, I wouldn't say you can only. It's easiest to add our fractions when the denominators are the same, okay? We can't just add this and say the answer is 3/7 because that's just not true at all, okay? And I'm going to prove to you that's not 3/7. So what do we have to do, Mr. C? What do we have to do in order to kind of get started adding this? Well, that's a good question. This is what you're going to do. We need to create equivalent fractions for both of these fractions here. So we're going to create an equivalent fraction for this, and we're going to create an equivalent fraction for this fraction. And what we're going to do is we're going to get these 2 fractions here, and once we have common denominators, so we want the denominators for both of these fractions to be the same. Once we can do that, it's going to make it really easy for us to add the numerators, okay? But how do we do that? All right, let me show you how we're going to go about doing that, okay? This is what you need to do. Over here on the side, and I'm going to use purple over here for my denominator of 4, I want you to list out both denominators, okay? So for both fractions, list out both denominators. So notice I listed out 4, and I listed out 3. Okay, this is what you're going to do. You are going to skip count by 4s. What does that mean, Mr. C? Well, just like when you multiply, you're going to skip count by 4s, right? It's a kind of a way to multiply. So this is what you're going to do. We're going to write them out. 4, 8, 12, 16, and I can keep going. And a lot of times students ask me, Mr. C, like how many times should I skip count? You know, it's a good question. And I usually just tell students, I usually go 3 or 4 just to start. And if I still don't have a common denominator, I'll keep going, and I'll show you what I'm talking about. Same thing with this 3. Skip count by 3s. So you've got 3, 6, 9, and 12. Okay, so we've listed these numbers. All right, we've listed out these multiples of 4 and the multiples of 3, and we're looking for a number that they have in common. Okay, we want to find a number that is like common. So take a look. This is kind of the strategy I have for solving this. I start up here with this first number. I've listed the multiples out, and I'm just going to take a look. Do you see 4 anywhere down here in the multiples of 3? Do you see 4 anywhere down here? I don't. So what I do is I just mark it out. Now let's move on to 8. Do you see 8 anywhere in these multiples? I see 9, but that's not the same as 8, so I'm going to mark it out. Now let's move on to 12. Do you see 12 down here? 3, 6, 9. Whoop, I see 12 in both of them. So what I do is I circle them. All right, I circle them because that is a common denominator. That is a like denominator. Okay, and a lot of times students will say, well, Mr. C, what if we didn't find one? You're going to keep going. All right, you would keep going because eventually you will find common denominators. All right, so what do we do next? We found these common denominators. So now what that tells us, I'm going to move this over a little bit. Whoops. Come on now. There we go. So now we know that our denominators for both of these fractions here need to be 12. Okay, the denominators for both of these fractions needs to be 12, not 3, 12. There you go, Mr. C. So what's next? What is next? Well, let me show you what is next. Now I'm going to rewrite this here because I want to make sure you can really see what I'm talking about. All right, so we know that the denominators for these two fractions need to be 12. Now here's the part where it can get a little confusing, but really follow along with what I'm showing you here. So this 4, we are creating an equivalent fraction, and this 4 is going to become a 12. And how is that going to happen? Is it magic? Are we just like closing our eyes and all of a sudden it becomes 12? No. This is what we're doing. We are going to multiply 4 times what to give us 12? 4 times what gives us 12? If you don't know, I've got a shortcut for you. Look at your multiples over here. How many times did we have to skip count to get to 12? How many times do we have to skip count to get to 12? Start here. 1, 2, 3. 4 times 3 gives us 12. All right, you following me? Okay, stick with me. So if we multiply the denominator by 3, anybody got any ideas what you need to do to the numerator? Here's something you're going to hear me say a lot. Whatever you do to the top, you do to the bottom. Whatever you do to the numerator, you do to the denominator. Whatever you do to the bottom, you do the same thing to the top. Whatever you do to the denominator, you do to the numerator. So if we multiply the denominator by 3, what should we multiply the numerator by? We're going to multiply the numerator by 3. So 1 times 3 gives us 3. Okay? Now, let's look over here at 2/3. 3 times what gives us 12? Remember, use your cheat sheet over here. How many multiples? That's going to be 1, 2, 3, 4. 3 times 4 gives us 12. Now if we multiply the denominator by 4, What do we do to the numerator? Multiply the numerator by 4. Okay? Whatever you do to the bottom, you do to the top. So 2 times 4 gives you 8. And so I'm going to write this underneath here so it's a little easier for us to see. We've got 3/12 plus 8/12. All right, let's solve this, and I've got a couple of questions for you. Are the denominators the same? Yes. Because they're the same, now it's really easy for us to add. Denominators stay the same. Add the numerators. 3 plus 8 gives you 11, and our answer is 11/12. Now I've got a couple of questions for you. Okay? This fraction here, 3/12, is that just a magical fraction that we created? Is this fraction 8/12 just a magical fraction we created because they both have denominators of 12? No, they're not just magical, okay? 1/4 is equal to 3/12. 2/3 is equal to 8/12. Okay, we created equivalent fractions, purple and purple, green and green. We created equivalent fractions that have the same denominators. When they have the same denominator, that allows us to easily add the numerators. If the denominators aren't the same, like we started out with, we can't just add these straight across. All right, we know that we can't just add these straight across. So what we had to do is we had to find common denominators. So that's why we skip counted. We listed out the multiples of our denominators. We found one they had in common denominators. We created equivalent fractions. Then we took those fractions and we added to get 11/12. All right? That is a lot of moving parts. Okay, that is a lot of moving parts. This can seem overwhelming, but we've already done this with models. If you don't remember, check out that video. Rewatch this problem here. Ask yourself some questions. Where did you get stuck at? Okay, that's what I always ask students when I'm teaching this. Where are you getting stuck at? Parents, teachers, don't let them just give up and say this is too hard. Ask them to tell you, okay, where are you getting stuck at? Where are you getting lost? Because if they can figure out where they're getting lost, then we can help them fix those mistakes. We can help them with those next steps, all right? So take a look at all this. Stick with me. Keep working hard. Growth mindset. And let's try this next one together. All right, second problem here on the screen. We've got 2/5 plus 6/10. First thing I'm noticing, denominators are not the same. So because those denominators are not the same, we need to create common denominators. We're going to have to find common denominators, create equivalent fractions, and then use those fractions to then add to get our final answer. Okay, so stick with me here. Let's do this. First step, now that we've kind of figured that out, list out the two denominators. Okay, list out the denominators. So we have 5 and we have 10. Now let's list out the multiples starting with 5. 5, 10, 15, 20. Again, I usually list out the first 4 and go from there. 10, 20, 30, 40. There we go. All right, same thing we did before. Let's take a look and see if we find one they have in common. Starting with the 5, do you see 5 down here? No, I do not, so mark out the 5. Do you see 10 down here? Whoop, right there. 10, 10. They both got 10, so that's great news. So we've both got 10. Do they have 15? No, I don't see 15. Now hold up, Mr. C. I'm seeing 20 here, and I'm seeing 20 here. Which one is it? Do I choose 10? Do I choose 20? What do I do here, Mr. C? Well, I've got kind of a long answer for you, okay? You can choose either, okay? You can choose either, but, this is a big but, okay, here. The reason I choose 10 is because I'm looking for the least common, okay? I'm looking for the smallest. I'm looking for the smallest common denominator. And the reason I'm doing that is because if I used 20, I wouldn't have a simplified answer at the end. I would have to do some simplifying if I wanted the simplified version. And that would mean that I would have a little bit of extra work to do. So I always go with the smallest number that they have in common. Can you use 20? Yes, 100% you can. I am going to be using 10. Okay, it's going to be less work for me at the end. That's what I always tell students, and that's usually what they always go for, is the one that has less work, and I don't blame you. Okay, so we know that the denominators for both of these fractions is going to be 10. So I'm going to go ahead and write that to where the denominators are 10. And now let's figure out how to make this happen. Let's create an equivalent fraction for 2/5. Okay, so we're going to multiply the denominator 5 times what? 5 times what gives you 10? If you don't know off the top of your head, use your cheat sheet, count the multiples. That's 1, 2. 5 times 2 gives us 10. There we go. If I multiply the denominator by 2, what do I do to the numerator? The same thing. Whatever I do to the bottom, I do to the top. Whatever I do to the top, I do to the bottom. So multiply the numerator by 2. 2 times 2 is 4. All right, you with me so far? Now, let's go over here. How does 10 become 10? 10 times what will give you 10? This one always trips students up because a lot of times they'll go, Mr. C, 10 times 0 gives me 10. Nope. 0 times anything gives you 0. So 10 times what? 10 times 1. All right, 10 times 1 is 10. Multiply the numerator by the same thing. 6 times what? 6 times 1 is 6. Notice this fraction here did not change. Why? Because the denominator we wanted was 10. It already had a denominator of 10. So we didn't have to do anything to it, but this is a good strategy to follow, okay? Let's rewrite all this. So we've got 4/10 plus 6/10. And let's see if we can get our answer. Denominators are the same, so we're not going to add them. They are the same. Add the numerators. 4 plus 6 gives us 10. There's our answer, 10 out of 10. 10 over 10, 10 tenths. Some of you are probably thinking, Mr. C, 10 over 10 is the same thing as 1, and you are correct. So now I've got a couple questions. 1, why did we list out these multiples? Why did we skip count by 5? Why did we skip count by 10? The reason we did that is we needed common denominators. Why did we need common denominators? We needed common denominators because 2/5 plus 6/10 had different denominators. That is hard to do. All right, it is hard to add 2/5 and 6/10 if the denominators aren't the same. So what did we do? We found common denominators. Ding, ding, ding. That was 10. We multiplied 5 times 2 to give us 10. We multiplied the numerator by the same thing. That gave us equivalent fractions. Again, like I showed you before, 2/5 is equal to 4/10. 6/10, we got the same thing because we already had denominators of 10, so 6/10 obviously is equal to 6/10. Once the denominators were the same, we were able to add, and that gave us 10/10. Okay? This is really one of those things that I don't find students, a lot of times I don't find, parents, teachers as well, I don't find that students see this as a really hard skill to learn. It's a process to learn. And what I mean by that is a lot of times students, we see this and there's so many things going on that we just get lost. We don't write clearly. We make a mistake in multiplying. We make a mistake when we're skip counting. And that's where the mistake comes in. So that's kind of your job, is to figure out, 1, where are you getting stuck at? What isn't making sense? Where are you lost? 2 is to find those mistakes. Okay? Parents, teachers, make sure they are finding their mistakes. Make sure they're telling you, I get stuck here. I make it to this point and then I get lost, okay? This takes practice. Stick with it, okay? I have a couple of practice problems in the practice problems video. It is in the description below. I'll also link it in the top right so you can check it out. Also, parents, teachers, have them get on iExcel. I've got those two links, one of them for a free 7-day trial and one for a 20% off memberships. Check those out. iExcel would be an awesome time to put 20 or 25 minutes of them practicing this skill, okay? So, like I always say, feel free to reach out to me. My contact information is at the end of the slide. If you learned anything new at all, click that like and subscribe button. Join us as we continue making math understandable and challenging. That's all I have for you, Mr. C.